starting a new project is the worst. But it's week 4, and we have the first deadline for our first assignment behind us. It was a recommended deadline, so don't worry if you're not done. But it means some of you have built your first game, and it's time to get started on the second one. If you open the course website and go to week 4, you'll see that what we will be building is a tile-based platforming game. Read this article to understand what benefits the tile-based engines give us and why they are so popular. These examples are top-down in perspective, but ours will be more like Super Mario Brothers, so side-scrolling platformer, that's what it means. Don't worry about, well, actually read this, because it explains pretty much exactly what we will be doing. This is very similar to the level layout data we will be producing, and this pseudocode very close to our actual implementation, or what we will be writing in a few episodes. If you haven't seen this syntax before, that's just an array of arrays, so allowing us to have rows and columns of data just like this. So apart from making it tile-based, we will have a few improvements. I have brought down the source code from the Space Shooter to my desktop. You will have more classes than I, because you have implemented more features, but there is a bunch of code here that we can reuse. The game class, the main activity, the jukebox, the entity, probably the utilities. You know, we've written some useful code. But we will improve on this code as well. In particular, our engine will be time aware this time around, so that instead of having entities moving a set number of pixels per frame, which is not very robust because the frame rate is variable and not under our control, we will have the engine work with meters per second. So we will have a metric system in all game logic and in the game world. We will say that an entity moves in 4 meters per second, and then however fast the game engine runs, the entity will always move exactly that fast. Of course, the screen is not in meters, it's in pixels. So we will have a game camera that allows us to translate between these two things. So only when we render will we ever care about pixels. Everywhere else, everywhere inside the game and the game logic, we will deal with meters. And then the camera will take care of, it needs to draw 8 meters of the game world. It will take care of figuring out how many pixels is that, does it need to scale the bitmaps up and down, and so on and so forth. We'll look at the details when we get there. It's not as complicated as it sounds. The only thing we have to keep, track of is that we sidestep the Android system's automated scaling of assets, and we already know how to do that by putting our assets in the no DPI folder. Let's just create our new project and get started. So we want something with an empty activity. I'm just going to call this platformer for our project. Java is fine. API 23 is our target. This is fine. Now, the main activity will be... We're not going to have a start menu this time, because we want to be able to just run the game and drop straight into the engine, so our iteration can keep the pace up. I don't want to click through a start menu every time. If I want to add one later, that's a trivial thing to do, because you know now how to add more activities using the manifest. So this is my main activity. We're not going to be using the layout, at least not until... We're going to be doing a virtual joystick or a virtual game controller, so that's going to be on screen, and we might use the layout system for that. But for now, I'm just going to go to the source code and look at my previous game activity and pretty much just grab all of this. We want the on resume, on pause, on destroy. Not sure if I mentioned it. Of course, the game now doesn't exist, right? We're going to bring that in shortly. I'm not sure if I mentioned, but the order in which we apply our callbacks to our parent class and ourself is important. So on setup, you want to call the superclass first, and then on teardown, you want to call it in the reverse. First, we destroy ourself, and then the parent class. Just a best behavior kind of thing. Probably because we're not doing anything much in main activity, we're mostly doing things in game, right? This doesn't matter much, but it's a good habit to get into. Set up the parent first, destroy the parent last. So I need the game class. I'm going to create a new Java class called game. I'm just going to leave everything as is, because I'm going to grab all the inheritance stuff from the previous one. I will clean this up. This will look like a mess, so just pour yourself a cup of coffee and bear with me. I'm gonna remove anything that has to do with gameplay and everything except, I think, the lifecycle callbacks. So on destroy, actually let's start from the top. Let's do this. So I don't need these preferences. Resolution is fine, I don't need that. That's gameplay settings. I need my thread and this running. I need the render stuff. We might move these to a separate class later on. I'm not super fond of having game extending surface view. I might want game to own a view instead, so that we can change what type of rendering we're doing. Like maybe you want to use a GL surface view instead of, or surface view GL, instead of the software-based one here. Anyway, we want an array of entities, so I might actually keep that, but we remove, remove the jukebox, remove all of the gameplay controls. Then actual height, scaling, that's good, stage width, blah blah. Set the entity game thing, get the holder, jukebox is removed, preferences is removed. We don't have player or anything like that. I'm gonna remove restart. I don't want the game to run until we have something to run. So restart can go. Run is good because we want our thread to have some work to do. This loop is going to be changing to take time into an account later. Update can be emptied until we have stuff to empty. Check game over can be removed entirely. Check collisions can be removed. We can bring it back later. You know, we still have the original source code. Render is good, but we can remove all of the entity stuff. Definitely remove render HUD. Remove this. Lock canvas is needed by render, so we're going to keep that. And then we have lifecycle callbacks. And here's some of the changes, some of the improvements we're going to do. Apart from making the engine time aware and metric aware, we are also going to be listening to the SurfaceHolder callbacks. So we don't start the thread in onResume. We're going to start the thread once the surface has been created for us. Some of you have already worked this out in your first assignment. That's cool. And the others, you will get the solution here. On pause is fine. Notice that I've done an improvement here that I'm not entirely sure we have on video, but we need to make sure that when we leave on pause, we never try to... We don't want to run any work, is what I'm saying. So we want the thread to absolutely be joined. You can spin on game thread state. I'm pretty sure there is a method for this. Get state, and then there is a bunch of thread. Let's see. Thread. What? It is thread. Oh yeah. Hang on. It was there. I saw it. Max priority. Is it thread state? Is that? There we go. State is what we're looking for. So you can spin until, for as long as it's not terminated, right? That's what happens when you join the thread. It waits for the run method to return, and once the run method has returned, the thread is set to terminated. That's the state, and you can't get it out of terminated again. You can't reuse a thread, so that's why we have to create a new thread every time we resume the game. Anyway, I'm just spinning on true until the join succeeds. If it succeeds, the return is executed and we leave on pause. If it throws, we catch it here, we log, and then we just try again until it succeeds. On destroy can be emptied of jukebox player and entity stuff. Game thread is fine. And so what I need now is the entity class, and I want the SurfaceHolder callbacks to start the thread. So let's start with bringing in the entity. Just the base class for now. So I'm just going to call that entity. I'm going to go to my folder here. That's the entity. Actually, let's just bring everything except the package name. That's the wrong window. I'm just making sure that I'm not making use of, say, any utilities or stuff like that. Want to bring in the game class. Why didn't that come in? Oh, it's still Space Shooter. It's the wrong package. I'm sorry. Let me go to the game class and clean that up. If we go to the top, this should be platformer package. And then we can probably refactor and clear out any unused, remove unused resources. Is not what I wanted. I want refactor. There should be a way of removing unused imports. Well, whatever. Easy enough. Maybe actually this works. Just optimize imports. Okay, so Alt-Enter over imports. It'll work it out for you. Perfect. Right. Paint is never used, but that's fine. The entity game seemed to still be wrong. So hang on, I'm in platformer here. My game is still a broken class because of this statement. Fair enough. So go to entity. I have to bring the entity in, of course. And I can't do that for some reason. It's in the platformer package. It's an abstract class. This should be static. I've broken the code. And now everyone is happy. Okay. Now, to deal with the callbacks. We have on destroy, that's fine. We're clearing up the game thread and the game reference. We have on pause, that's fine. We have on resume. We set his running, we create the new thread, but we don't start it. So the next thing we want to do is have the callbacks from the SurfaceHolder so that we don't spin in update because our thread started in on resume. Here's what I'm trying to say. On resume happens a pretty long time before we get a surface in terms of CPU time anyway, maybe not so long time for us. So we also want to implement SurfaceHolder callback, not callback to callback. So we implement runnable and we implement SurfaceHolder callback. We do implement methods. We want all three of these. It adds them at the end, and that's good because all of these are, of course, executing on the UI thread. Executing on the UI thread. So we don't want to do any needless work. Now, you might want to log here, so surface created, so that you can see how long it is between on resume and the surface being created. Also, I want these to be final everywhere. I wonder why it doesn't auto-generate with final for these arguments. Final, 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 final. So, surface changed is a callback we get when the surface changes, like when you rotate the phone or when it sets up the first time. So, SurfaceHolder, let's call that actually like this. Surface changed and then log what size we got. So I'm going to add /t. That's a tab to bring the text in a bit so I can read what it says, and just do width, height. The last argument here, you have oh, no, sorry, that's actually the first argument. Format, width, and height. This is what sort of color format you have on this surface, but we don't care at this point. And in surface changed, this is where we want to start the thread. So first it's created, then it gets all of its configuration set, which is where we get surface changed from. So acquired, resized, we get a changed call, and then we check, are we meant to be running? Then please start the thread. So basically, if we have game thread is not null, it's not an M, it's underscore like that. If it is not null, and if we are running, i.e. we are meant to be executing, then start the thread. And we might also want to log that. So game thread started. I'm gonna rename this to be consistent in my log output. Lastly, we can of course also log surface destroyed. What's important to know is that once surface destroyed returns, we cannot access the surface again. It is undefined behavior. It will crash and kill us. So we need to make sure, absolutely sure, that once we've received this, we don't use the surface again. And that's why we're going to keep our suspenders and the safety belts. We always check that we have a valid surface and we lock it before we use our render code, right? We have this check always to make sure. So this is inside render is the only place we use the surface. Render always checks that we can lock it, and while we hold the lock, the surface is guaranteed to be valid, meaning we are safe from using it out of order. With the surface destroyed, we don't have to worry. No, sorry, what I mean is we don't have to worry about it in surface destroyed because we are making sure in the render method. But yeah, it's a thing you need to be aware of. After surface destroyed, the surface cannot be used or we will crash. But we are good, well-behaving citizens because we always lock the canvas and release it when we're done. So this should work. Now we should not be running until we're ready to run. I might want to add an update here. This is of course going to flood our output, but whatever. And at this point I realized that I have to launch my emulator. It's going to take forever, so you might as well just move on to the next video at this point. But let's see if it compiles. Oh, that launched quickly. Let me double check here. Main activity. How did that compile? Doesn't seem to know what game is. Come on. No. There we go. So it's just the editor hadn't updated. Here's our emulator. We're not in full screen, and we're also not locked in rotation. We need to edit our manifest to make sure that we are locked in full screen. Locked in rotation, and then set ourselves to full screen. But other than that, it works. Let's look at the output. We have logcat. I want from my game. Thank you. And then here's the resolution. Here's on resume. On resume happened at 14:15:06. There is an on pause, on destroy. Where is? So it did an on resume and an on pause without setting up anything in between. Not sure, because I haven't. We can probably trigger this. There we go. So here's on destroy. And then we have the game starting up with a resolution. Then we have on resume. This is not in any order that I would expect. I'm not seeing those callbacks. Have I failed here somewhere? Let's see. In particular, I'm noticing we haven't, like the thread is not in fact starting, right? I'm not getting the callbacks. So game is a surface view. It implements the SurfaceHolder callbacks. Oh, yeah, I have to actually tell the holder that I need to listen to it. I think. Add callback. This. And now we're running. Cool. So let's stop this. Actually, let's do this first. We do that. And then stop it. So here's surface destroyed, right? And we're no longer running. I'm gonna scroll up a little bit. On destroy, on resume. So there's on resume, then surface create, then surface change. On resume happened at 17:05. We got the configuration change. Well, I don't know what that is, like 100 milliseconds. No, is that 100 milliseconds or is it 1 millisecond? I'm not sure what the unit there is, but there is a bunch of time passing before we have the surface available. But at this point, we start the thread once the surface is there, and so it's better. All right, we need a level format and a way of rendering the level and then a camera and all kinds of stuff. So I'm gonna stop recording here and I'll see you in the next video.